It's interesting to note that every planet in our solar system has its own unique color, making it clear that our world appears to be a different color from space than what we see up close. You might be wondering why the planet's colors are different when they are all located in the same orbit and orbiting the same blazing sun. Well, my friend, it's because the planet's colors are influenced by several factors. For instance, the composition of their atmosphere, the presence of certain gases, and the reflection of sunlight off their surfaces. These factors contribute to the distinctive hues of each planet, making them truly unique and fascinating to study. Did you know that color is more than just a visual cue? In fact, it's more of a communication between the brain and the eye than it is a physical thing. When we see colors, our brains are actually converting the light absorption through color perception. So when we look at an apple and see that it's red, it's actually just our brain telling us that the apple is reflecting a certain wavelength of light. Our light receptor cells are pretty amazing, as they translate the approximately 1 million hues that surround us on Earth. And when we look at our planet from space, the most prominent hues that we see are blue and green, which are depicted by the angle of light reflection. Cameras on the International Space Station can even capture the beauty of bright deserts and snow-capped mountains from up above. It's all about perspective, light, and angle. But have you ever wondered what gives other planets their unique hues? For example, what gives Mars its distinct red color, or Saturn its light yellow-orange hue? Well, my friend, the answer lies in the composition of these planets' atmospheres, the presence of certain gases, and even the way that sunlight is reflected off their surfaces. So the next time you look up at the night sky and marvel at the colorful planets, remember that there's more to color than meets the eye. It's all about the communication between our eyes and brains and the unique characteristics of each planet that make them truly special. The substance found on a planet's surface can affect its color. Take Mercury, for example. The majority of its surface is made up of graphite, a carbon-rich substance. When we look at Mercury through a telescope, its jagged graphite surface appears slate gray, almost as if someone drew the planet in pencil and forgot to color it in. But wait, don't confuse Mercury's gray with the Moon's gray. The Moon's surface is gray due to iron, not graphite. And interestingly enough, there are graphite patches all over Mercury, not just on the planet's surface. These patches are probably even beneath the planet's crust, giving us a hint of what the planet may have looked like in the past. So you see, my friend, the elements that contribute to a planet's color can be hidden beneath the surface, as well as observable on the ground. And if you really want to get into the nitty-gritty of this amazing visual science, you'll learn that even the elements floating over each planet's surface can affect its hue. It's incredible to think about how the different substances and elements that make up each planet contribute to its unique color. It's almost like each planet has its own signature color palette. Colors of the planets are influenced not just by what's on the surface, but also by what's in the atmosphere. For example, Venus has a thick atmosphere of carbon dioxide and sulfuric acid that gives it a burnt orange and pale yellow appearance. If you were to take a trip to Uranus, which sounds like a fun vacation destination to me, you'd notice that its soothing blue hue comes from little concentrations of methane in its atmosphere. But what about Mars? Ah yes, the red planet. Mars gets its signature reddish appearance from a combination of factors. You see, Mars is rich in iron, from its surface all the way down to its core. Normally, all that iron would make the planet look gray. But because Mars has an atmosphere rich in oxygen, the iron oxidizes and takes on that rusty red color we all know and love. It's like if you left a piece of metal outside for too long and it started to rust, only on a much larger scale. You might think that the color of a planet stays the same no matter what, but that's not always the case. Sometimes wild weather can turn a planet into a whole new hue. Take Jupiter, for example. We all know that this gas giant is pretty stormy, with its famous Great Red Spot being a huge vortex that's been swirling around for centuries. But did you know that other colors on Jupiter are also caused by extreme weather? Those white areas you see are actually milder storms with less intense winds, while the brown spots are warmer storms that move through the clouds. And get this, some of these stormy regions can change color depending on the temperature at their core. So what might have been a fiery red spot yesterday could be a bright white area today. It just goes to show that even the colors of planets are subject to the whims of Mother Nature.